So now that we've learned about radians, it's a good idea for us to go back and revisit the unit circle and those important values. We know that 30 degrees, 45 degrees, and 60 degrees are very important. So let's start with a 30-degree angle. And we can think about a 30-degree angle as just being 1/6, 30 out of 180 of a 180-degree angle. And since 180 degrees equals pi, 30 degrees equals pi over 6, which means 60 degrees. So if we go another 30 degrees over, which now makes a 60-degree angle, our angle becomes not pi over 6, but 2 pi over 6, which is pi over 3. And then we can keep going. If we add another pi over 6, we get to 90 degrees. And another pi over 6 is 3 pi over 6, which equals pi over 2. And then we can keep going and get 4 pi over 6, which is 2 pi over 3. And then finally, 5 pi over 6, which is our 150-degree angle. And what you can see is it's just a matter of multiplying the pi times whatever you need to multiply by to get to that 30 to get to that angle. So 150 degrees is 5 pi over 6 because 5 times 30 equals 150. And then we keep going and we can get our 210 is just going to be 7 pi over 6. 240 is just going to be 8 pi over 6, which is 4 pi over 3. If you notice, the 60-degree angles are pi over 3, 2 pi over 3, 4 pi over 3, and then the next one over here is going to be 5 pi over 3. And then finally, our last one, 330 degrees, is 11 pi over 6. And so the 30-degree reference angles are pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. And the 60-degree angles are the pi over 3s, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Note that 3 pi over 3 is just 180, or 6 pi over 6 is just 180 because they both equal pi. The other thing is to recognize the pi over the 45-degree angles. Well, if you do 180 divided by 4, that gets you 45 degrees. So pi divided by 4 is the 45-degree angle. If you add pi over 4, that gives you 2 pi over 4. That's your 90 degrees, which we already know is pi over 2. Add pi over 4 again, you get 3 pi over 4. And you recognize that each of these 45-degree angles are just the next odd number over 4 times pi. And so the 45-degree angles are pi over 4, 3 pi over 4, 5 pi over 4, 6, 7 pi over 4. And they're just the 45-degree angles in each of those quadrants. So when you're looking at a pi over 3, that's the reference angle 60 degrees. A pi over 6, that's a reference angle 30 degrees. And a pi over 4, that's a reference angle of 45 degrees. So if we want to find out, well, what's the exact value for 5 pi over 6? Well, 5 pi over 6 just is right here, which is 150 degrees, which gives you a reference angle of 30, which means on the unit circle, this coordinate is going to be a negative root 3 over 2 and 1/2. So when we start calculating these, cosine, sine of 5 pi over 6 is just going to be the y value, which is 1/2. Cosine of 5 pi over 6 is just going to be the x value, which is negative root 3 over 2. And then tangent of 5 pi over 6 is just going to equal the y over x, so 1/2 over negative root 3 over 2, which turns out to give you negative root 3 over 3 when you do some simplifying. And then our other three values are just going to be the reciprocals of that. So cosecant of 5 pi over 6 equals 2. Secant equals 2, a negative 2 over root 3, which you can simplify. And then cotangent of 5 pi over 6 is just going to equal the reciprocal of 1 over negative root 3, which is just negative root 3. And so you can do this just like we've done in the others. If you're doing 7 pi over 4, I'm just going to do the 3, the cosine, sine, cosine, and tangent, and you can do the reciprocal. But 7 pi over 4, that's a 45-degree angle. and it's not pi over 4, which is the first quadrant, 3 pi over 4, which is the second quadrant, 5 pi over 4, which is the third quadrant, and then finally 7 pi over 4 is in the fourth quadrant. And so it turns out to be a 315-degree angle, or you could think about it as negative 45, or negative pi over 4. And so your coordinates here are just going to be root 2 over 2 and negative root 2 over 2. So sine of 7 pi over 4 is just the y value, which is negative root 2 over 2. Cosine of 7 pi over 4 is just the x value, which is positive root 2 over 2 because you're in the fourth quadrant. Cosine's positive there. And then the tangent, well, is just y over x, which turns out to be just negative 1. Take the reciprocal of each of those, and you'll get the other three values. The last one, 7 pi over 2, well, on this one, 2 pi, or 4 pi over 2, is 360 degrees. So if we subtract 2 pi, it's like subtracting 360. That gets us 3 pi over 2. Well, if each pi over 2 represents 90 degrees, 3 pi over 2 just represents 270. And so the coordinates there are just going to be 0, negative 1. So sine of 7 pi over 2 is the y value, which is negative 1. Cosine of 7 pi over 2 is the x value, which is 0. And then tangent of 7 pi over 2 is negative 1 over 0, which we say can't be done, so we call that undefined. Finding the cosecant, that's just the reciprocal of sine, and so that's going to be negative 1. Secant is the reciprocal of cosine. Well, the reciprocal of 0 is undefined. And then cotangent is the reciprocal of 7 pi over of tangent, but tangent was negative 1 over 0, so the reciprocal, that's 0 over negative 1, so it actually turns out to be 0 and not undefined. So that's how you find exact values given radian degrees.